Yo, what's up, everybody? Welcome back. Today we are working on our virtualized GPU. And today's topic is continuing on with shader implementation. So, context for the project. We have this idea where it would be fun to make a GPU on an FPGA one day, right? But a big blocker to that idea is knowing what the hell a GPU does, right? Right, we could kind of like make some guesses that it does a lot of like parallel floating point computations. It probably has some sort of like render pipeline that takes triangles and like figures out how to iterate those triangles and knows how to do like triangle interpolation so that it can do like fragment shader stuff, whatever, right? But like, what does it like really do? Where does software end? Where does hardware start? That's like a question that we would like to answer. And so we kind of figure the best way to tackle that problem is by just kind of implementing the whole stack ourselves, because reading is too hard, right? So what we have at this point in time is we have a QEMU virtual machine. We did not write this. This exists already. This is an open source virtual machine. People on Linux use it and love it. It's great. We have extended this thing since it's open source with our little PCI device, right? Our PCI device is capable of drawing to QEMU's virtual display. So, if we want to draw a smiley face in there, we can do that by iterating pixel. We can like allocate a image, put some pixels on the image, display on the screen. Great. We have a kernel driver that lives in our like Linux, kernel that is being booted by QEMU, and he implements a DRM device. DRM, not digital right management. Fuck that stuff. We're talking about direct rendering manager. So we have a kernel driver that basically looks for the ID of our PCI card and knows how to talk to him. Our PCI card basically says like we have a few registers that are allocated in like as memory mapped addresses, I guess we can say. And we have like basically a command plus argument format. So our kernel driver can say, I want you to perform this action, here is the command ID, and here are the arguments of that, and the PCI card will like look at those written data and like do appropriate things. We have this thing. The kernel driver exposes this DRM system to user space, which basically gives like kind of like a common format that like applications can expect to use. So we have like user space here, and we have like an application that talks to this thing, right? So the way this works is he opens a file handle to this DRM device. It lives in like dev DRI card 1 or card 0, card number, I guess. And he exposes like this kernel mode setting API, which is kind of like the base, like this. If your GPU is like dumb as bricks, it will still support this thing. And it's basically like, I want to write this picture to the screen. That's kind of like all it supports. But that's very useful if you want to have common code for like showing like a virtual terminal or like a boot splash screen, stuff like that. So that's working for us right now. And we are kind of on the saga of implementing OpenGL. So the idea here is that there's this library called Mesa. Mesa, boom. And he basically has backends for each GPU. So one of like the like common APIs here is like, what's the name of my GPU? And then we ask the name, and he says, I'm a Sphero GPU. And in Mesa, we can add a library, like add some backend stuff to say like, if you see the name Sphero GPU, run this set of commands when stuff happens. And so we've been slowly working through there. So we have like these like extension commands. You can like extend the DRM interface with like your own custom octals. So we have stuff for like alloc buffer, right? Buff. And like clear screen. We have like an API for this. And so what happens is in Mesa, when you call a command like gl clear, he basically calls into a backend, your backend driver down here, like driver, right? He calls into your backend. We say, oh, you want to call clear? I'll call clear on this guy. And then he clears the screen on the PCI device. What we are working on at this exact moment in time is we are trying to get this triangle to show up on the screen. So if we have a little test app, and if we run him on not our GPU, but like an existing virtual GPU implementation in QEMU, we see a green screen flashing and then this triangle that's off the screen because we fucked up our coordinate system. If we run that same app on our card though, we see the same green screen, no triangle. Why is that? Well, OpenGL applications, they expect to draw stuff. They use this like shader pipeline. So the idea is that you write a program. Let's see if we can bring it up somewhere. We go to like source test app, cd test app. Here we go. you write a program that you say, for every vertex on my model, I'm going to upload this like 3D model to your OpenGL world, and for every vertex on this thing, I want you to like perform some action, right? So in our case, we do nothing. We just take the input and we pass it on. You then write a fragment shader that says, for every pixel, for every triangle that is being drawn in this model, please do something to the, like, here is the color of that pixel. Right now, we just set that color to 1, but you could do stuff like tag each vertex with some like interesting data and like interpolate between them so that you can like color the thing. Or you might like be like, texture map that thing, right? So you have an image that gets like wrapped onto this like model, and you want to sample from the image in this fragment shader. That's kind of like the OpenGL way. So the idea is that you have like basically like vertex shader, fragment shader. You take like data, right? This goes in here. This runs for each element in your data. Then this runs for each pixel for each element. Boom, you get your output. Now, the problem here is that the simple case of just drawing a fucking triangle to the screen means that you have to implement all of this. And what this is like, well, this is like text. Surely your GPU doesn't execute that, right? So what happens is you feed this into Mesa. You call like OpenGL, please compile my shader. Mesa goes, okay, sure thing, buddy. Here we go. Here's some like intermediate representation. And then he feeds that intermediate representation to our driver. We have to then convert that into like specific GPU instructions that we can execute. And that's what we've been working on yesterday. So if we look, where do we look here? Let me get into the right environment here. One sec. We have built this library that we're working with. We call it libgpu. And what we've done is we've taken the debug output from shader compilation in Mesa. So if we look at like nerd debug, I think it's called, is equal to print vs. I think it's what I want. Hell yeah. So what happened? What we did when you call this command is we say, hey Mesa, when you're compiling your shaders, could you please just like tell us what you did, please? Thank you, thank you, thank you. And he prints out this block of code. So he says, for your simple as shit vertex shader, which just passes your thing on, he says, okay, so we have this variable input apos, that's this. He has a output GL position, that's this, and he basically says, deref this thing, this input, take the data in that thing and put it in some variable. We're going to load a constant into a second variable, and then we are going to store that thing. So the thing you loaded, XYZ, plus the constant we loaded, we're going to put that in the output. Simple, 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 right? We have implemented, as of yesterday, the commands in our GPU library that map directly to this. So we've written our little test case here, which basically says, hey, I'm going to like create a shader. I'm going to push an input with a vector 3. So that kind of matches this thing. I'm going to add an output, which is this thing. We are going to load, and then we basically mapped these commands one-to-one. So we have like load reference of input 0. That matches this, right? We say variable 12 takes in is a reference to input 1. Essentially, right? That's essentially what we're saying here. Then we load a command. This load represents this. So we say, like, okay, so we have a register that has the address. Let's dereference that thing and store it in a vec3. So that's what this thing does. We say, could we load a constant? Boom. And then could we reference the output? Could we execute the move? Store the output. Great. If we execute this shader, which basically just like rips through command by command and like basically stores variables in this like map. We never delete a variable. We don't do anything intelligent. We do no like register allocation. We just say like every variable is a unique number, and we like store these things in here as we go, and we know which output maps to which one of these variables. So we just kind of say, okay, we'll map this one-to-one, execute it, do something. That seems to work. We get an output that we expect. We see our output is a vec4 that is a combination of 1, 2, 3 plus our constant, which matches up with this 1, 2, 3 plus our constant. Wow, huge win for us. So today's topic is going to be trying to integrate this with Mesa in some way. So what we have completely skipped here is the idea of like serializing and deserializing the shader. So we've kind of like created an instruction format that is probably not a very good GPU instruction format, but it maps very well to Mesa. we are going to have to basically take this command set and turn it into some sort of binary representation. We are going to have to take that binary representation and transfer it to the GPU. And then on the GPU, we will basically use the same library to decode that thing back and run it. Bing, bang, boom. That's like a pretty good target for today. Now the problem here is we wrote this in Zig because we're tired of writing C. Fuck that language. I mean, it's okay, but it's like, there's a lot of silly shit about C. And we need to expose the generation of this shader. So we kind of have like basically these commands here where we say like, I'm going to do this command, then this command, then this command. This needs to get exposed to C so that we can push these things. And so yesterday I kind of got stuck on like, how is that going to look? Off stream, I just kind of like stubbed out what a couple functions could look like. So push input vec3 and you take an XYZ. Push output vec4, XYZW. Push command load input reference. Here's this ID and index. I think I like this scheme. So we'll just kind of like make a function for every single variable that we could feed in, and we'll just kind of handle the ones that we run into, and anything that's not that we don't run into, then we don't need to represent because we don't really care about this being like a generic library that works. We just care about it being good enough for us. So step 1 is going to be writing whatever APIs we need to write in order to compile the shader for Mesa. So let's start there. We're going to have to add a compilation step as well, but we'll kind of get there. Later. So let's open, I guess, Mesa in this window and kind of just start walking through our shader compilation stuff. So we're in Sphero DRM Winsys. Let's make sure that we are kind of in a clean spot. We sure are. We are chilling. Are we at the tippy top? It looks like we are. Hell yeah. And we are in like create VS state. Here we go. So in here, we have to basically walk. We've started walking every operation, kind of. Well, let's see. We're walking every function that has been given to us. Then we are walking CF nodes, which I think is control flow nodes within the function. We're like, okay, we got a block of data, and let's walk each instruction in the block. In here, we have like seen some instruction types that are like, I think ALU is like, I can't remember. It's like some sort of like arithmetic logical something. NUR ALU Mesa. Let's see what it stands for. ALU stands for simple operations. Oh yeah, so I just never knew what it stood for, which is why I couldn't remember. Simple operations. So this, I believe, is the move we see here. We see this vec4 move. This is going to have to get compiled to something. But before we get there, we want to kind of start at the top. So let's look at that. So I think if we go here and we go, please run my virtual machine again in the background, please. Then we can go in here. We can run our app again. And we can run it with NUR debug is equal to print VS. Arithmetic logic unit. That would make sense. And so we need to first figure out how to push this deref var thing. Well, that should be in our shader thing. Since we have kind of run this whole program already, we should basically have something that's equivalent to push input here. Now, what's a little odd is we have pushed the input value here, but really we should be pushing the input type here because the shader is not executing at this point. What about feeding the driverless SPIR-V? I had not really heard those words before, and it's not like the thing that naturally is given to us by Mesa. I understand now that SPIR-V is like this like generic shader format, but I think that what happens usually is like that shader, the SPIR-V will get compiled into Mesa IR and then fed to us, right? Because I imagine that if you're using SPIR-V, you will be, in the like vast majority of cases, being compiled from SPIR-V into whatever the driver expects, right? And since like Mesa is our GPU driver, then surely SPIR goes to NUR. I started yesterday, might as well continue. There's also SPIR-V to NUR. Nice, okay, yeah. So that kind of lines up with my understanding. Um, okay, so I think we've kind of made I think before we get into integration with Mesa, I think what actually makes more sense is to split the idea of shader compilation and execution. So let's start there because like the idea here of pushing an input value to the shader is wrong, right? That's wrong. We should be pushing an input type, and maybe I think we do need to. It does need to know the types. I'm pretty sure. We'll see. Because like once this shader gets executed for real, I guess probably what's gonna happen is we're gonna feed it like a buffer of a bunch of floats, right? Like the way like the OpenGL API works, you say like GL you like create like a GL buffer with like data on it where you pass in like a bunch of like float threes or whatever, or float 32s, and then you say like GL, you say something that basically says like what the inputs, how these things are formatted in memory as arguments. So presumably each argument will get like an address or something. Probably. We'll probably have like some memory somewhere, and we'll run the program and we'll say add input 1 is pointing to this address. That's my guess. And I think it's a fine initial guess, even if it's wrong. Working under that model will give us a reasonable starting point. Okay. So let's take this shader and split out execution. Uh, and so in here, he's gonna have like a function execute, and his inputs are going to just be like probably a list of addresses. I think that makes sense. Yeah, that feels like it makes sense to me. So we're gonna take in like inputs. And what's like the address type in this language? Any opaque? Yeah. Okay, and he's gonna return more addresses. That seems reasonable. I guess we don't have to get this crazy. Let's like put these as variables for now. That feels a little bit more sane. Okay. So all of this execution stuff, I guess like all of these like variable tracking kind of live here now. And inputs and outputs also lives here. Which means that like this is probably fine. Everything in execute can just go in here now. And now we just have to go we have to store the shader in here probably. So we're gonna be like, shader is a shader, right? For now. And yeah, we'll do this. That's fine. So I guess inputs and outputs actually don't become arrayless here. I guess really none of these things have to be none of these things have to be like member variables actually. These just kind of live here. Inputs comes in like this. Outputs is going to be an array list variable. Okay. And var SSAs is going to look the same. It's going to be like a hash map of shit. I don't know. Okay. So now everything here, self SSAs is just our local variable. We probably need to defer like this. Okay. self inputs now is just inputs. I guess it's anything that said self inputs items here is now just self. It's just inputs, my bad. Okay. And then this resolve channel ref is now lives in the shader executor. Okay, and now since self inputs and self outputs are not here, we have like this gets passed with no self probably, and he has like inputs, outputs, and SSAs, which is a stood auto hash map unmanaged of something to something. U32 to variable probably. Probably something like this. I don't know, man. So this is inputs, outputs, SSAs like this. Okay. Inputs, outputs, items, SSAs, and boom. Okay. Seems reasonable so far. Seems reasonable so far. Our shader is probably going to have to... He wants to track, like, input types. And the output types, probably. Just kind of how it feels. And then when we were compiling this thing, we were just going to take a variable type here instead. Okay, sure. Seems reasonable. Now, here we are going to have to, like, sanitize inputs. Seems reasonable to me. And we have to set the outputs. If we're going to be like using these outputs as references later, we have to push outputs for each output type. Seems reasonable to me as well. Seems reasonable to me. So we go like for self shader output types. Items. Here we go. We have item. Maybe output type. Boom. We say outputs.append. This is gonna have to be like try outputs.append with self-alloc and the output type. So I guess we're gonna be like, can you? I guess you like switch output type. Can you do something that's like var output var variable is equal to output type? Is this allowed? I'm not sure if that compiles, but it might. I assume it doesn't, but we can dream. That'd be very cool. Okay, then our just test now, instead of running shader execute, he needs to be like const shader executor. Who has alloc is equal to alloc, and the shader is equal to shader. This should work now, and then we just say like outputs. Here we should like assume that we have one output. I guess we need to execute this with our inputs. So this is where our vec123 comes in. All right, we go boom. And we should expect a single output. And our outputs 0 should be this. That feels pretty good to me. All right. Surely this fails. Variable type 192. So push input here. We now need to push the input type. So vec3. Okay. Push output gets vec4. Okay. 174. He's mad because it should be input types now. Output types like this and like this. All right. Execute needs us to be non-const, but I don't really actually think we do. I think this can work fine as a constant. Variable does not support struct initialization syntax. Set 272. Good afternoon. Waving, hello. And then what goes next here? What were we fixing? Does this need to be kind of like this? I guess this needs to be a slice, so this is actually kind of more like this. I think this is what we're supposed to do. I think that seems right to me. We need to put an ampersand on this thing to coerce it, sure. And then I guess this should be constant. That is fine by me. Okay, so he doesn't like coercion from variable type to variable, which has non-void thing. So can we... Is there a way, does any like Zighead in chat know if there's a way for me to take a enum that is like tagged with the unit and just set it to undefined? Like I want like to have variable type as an input and just get the undefined thing as the output. It seems like that should be possible, but I don't really know how. You could like, I could imagine something that's like this, right? Like this feels like a syntax that could theoretically work, but here it doesn't like that. Is there like a, can we do like this is equal to undefined and then be like output var dot like type? Like, can I just like set the tag only? Zig union set tag only. Unions. Union enum tagged. Fine. I mean, we can just do it the right way, but it's annoying. Like, this seems silly. But I guess like this allows us to force like default initialization, which is fine. Right? I don't know. I think there's a meta method that might help. Tag payload, maybe. Given a tag union type and enum, return the type of the union field corresponding to the enum tag. No field So this gives me like a type back. Oh. And there's also comp time. Yeah, it's fine. It's fine. It's fine. We'll just do it this way. It's fine. It's F32 reference. And else, we'll just say panic, unhandled output type. I guess we could do this for, we could specify these manually still, so that if anything is changed in the future, we'll still get the compiler error. Okay, there we go. Fine. Fine, we'll do it like that. It's good enough for me. 93, he's mad at self commands not existing. So this is shader commands items. And then he's mad at no outputs at 110. So this is outputs here. Okay. No field name outputs instructs shader executor 123. True. Reference pointer cannot assign to const, so 126. Reference pointer probably is because outputs here. It's a variable. Oh, because inputs is a const variable. Oh. I see. So how do we want to do this? If we want to modify an input variable, which we might for some reason want to do, then for now we'll say inputs, we'll call this inputs const. And we'll say this is a alloc dupe variable from inputs const. There, that's probably good enough. To bail us out for now, this is just resolve channel ref with no self argument anymore. And then we need to return our outputs at the end of this whole thing. Like this. Like this. And then no member named items at 144. Sure. That's true. Then we'll probably have a leak here. Yep. Yep, leaks. So the leaks here mean that we need to defer self alloc free outputs. Is that it? There's another one at the inputs, right? Because the inputs that we duplicated definitely need to be freed. All right. You can switch on the inline. You can switch on the enum, and inline else can make the tag comp time known. How is that possible? I don't see how you can take a runtime value and make it comp time known. That seems impossible. Seems impossible. Okay, so it looks like this is working, which is chill. So now we just kind of adjust our C API now to say we're not actually pushing inputs. We're pushing the types. Okay. Which means that in Mesa, you're saying like to do switch tag inline else compile time tag. I am like 95% certain that this would not compile if the tag is actually not knowable at compile time, if that makes sense. I expect that that inline else will still iterate all of the unused options at compile time automatically and generate the different cases for those with like the same output, if that makes sense. I could be wrong, but like it's impossible to get an unknown thing into a known thing. It's just like it's not possible. So it must be that way. Okay. So let's look at this thing now. Okay, our inputs. We need to, I guess we won't have inputs and outputs handled yet. We'll just start with only pushing the commands, because that's kind of where we're at here. So we need to do like, let's do a zig build just without test. Okay. So let's do like, we need to create a shader. libgpu shader, we'll call it. Struct libgpu shader. libgpu shader is equal to libgpu create shader. Nice. All right. Start there. This needs to write void in here for it to be correct. And this needs to have a star on it. Then we will say we need to do something here. So this is going to be ner instruction type deref is this thing that's like basically load a pointer into my thing. So this is libgpu shader command load input reference with our libgpu shader. The deref index this needs more, I think, input reference. Load reference needs source and input. Oh no, that's fine. Okay. So what is in this like ner deref instruction? I don't know why this fucking isn't like resolving correctly. But it's annoying, but it's fine. Can we just look for like ner deref inster? Here we go. So do we have like the input? Do we know for like an input or output variable? Like ner deref type var array struct pointers array. Okay. So let's kind of figure out, we'll have to look at like what the deref type is. Printf deref type. Oh, we already have this. Hell yeah, we've already done that. Okay, so we know we're a variable. Hell yeah. So if we're a variable, we must be in ner variable. So ner variable has the index. Okay. Does he also have like if he's an input or output or what? Like exec node, glsl type, the name of the variable, ner variable mode, storage class, precision. This looks like kind of like storage info. I'm kind of more interested in location maybe. This looks like what I want, right? Location. Depends on the nature of the variable. So we kind of want like glvert attrib. We need to know if this is an input or output. So how do we know that? That's kind of the more important info. So they have this here. They write shader in vec3 in the when they print out the shader IR. So we can go to like ner print.c and try to look for like this. So it looks like this comes from the variable mode, which comes from var data mode. Okay. So we should be like var it was deref var data mode. Let's start here. Let's start here. I spelled build wrong. It's hard life. Hard life. So he wants a pointer here on var. Otherwise he's happy. Nope. Undefined reference to libgpu create shader. Right, so we actually have to implement these functions. I forgot. I did forget that, huh? So if we go in here, we do like a pub export function. Libgpu create shader, who takes in nothing and returns a GPU shader. Shader, maybe we called it. Nice. We can go global dot GPA allocator is our allocator. And we can do alloc shader, except this would be create. And then we go shader dot stars goes shader init. Is it like alloc is alloc? Is that what we want? Yeah. He's mad because we need to try this, so let's do or else return null like this. Catch return null, I guess. And then here we need to return the shader. Boom. Simple. Easy peasy. Okay. So now we go here and our build should hopefully find the shader creation. Nice. Nice, nice, nice. And if we build this thing and copy all of the relevant libraries over and try to run it over in our virtual machine, we can't do that because our virtual machine needs networking up, which we have not set up yet. Boom, boom. Copy all the relevant libraries over, which are massive because they're full of debug info. Let's give her a looky. Okay. So what are we even trying to look for? Oh, fuck. Printf doesn't work for whatever reason. Standard output is being clobbered. When I run over SSH, never looked into why. I should at some point, but you know, you can't make me. Instead, we will just print a standard error. And we should see drf mode 4, drf mode 8 is what we're seeing there. Okay, so ner drf instruction. What is it? We go to var data, and then it was mode. What was it? It was drf var data mode. Yeah, okay. Oh, here, mode. Here we go. So this thing has what it was 0, it was 4 and 8. So 4 and 8 here. Okay. All right. So if dref var data mode and ner var shader in, because this is a bit mask. So this and ner var shader in. We have to push the type, so we need to know what the type is. What is wrong with this thing? I guess I'll just put fucking squiggle brackets there. Looks like that's fine. I don't know what the fuck was going on there, but whatever. It looks like at least the fucking thing is happy now, the language server. So I think that our output here did have a type here. He does. So how did he get that? Ner print. So we're looking for print deref instruction. That sounds right, right? This is deref var. Then he puts the ampersand here. Then this is the shader in after the bracket. And then we're looking for the glsl get type name. So this comes from glsl types. And this comes from instruction type. Okay. Okay. We can live with that. This has a name ID. I'm not entirely sure about this, to be honest. It feels like not necessarily what I want. But maybe it's fine. This is probably suboptimal, but whatever. This comes from the instruction. So that seems fine. I don't know why he's mad about this. Unused. Oh, he's just because I forgot to put a fucking semicolon. I see. Oh, wait. Instruction's the wrong thing here. Let's go back here. So, where the fuck were we? Here. Instruction here is a ner deref instruction. Ah. I see. So it should be deref type here. Nice. Okay. Does glsl type give us like a nice little name ID? Like, surely glsl type here? Base type? Like, surely there's like a vector 3 in here somewhere. We have the base type, sample type, vector elements. So I guess we are expecting a base type of float with 3 vector elements, right? That's kind of what we're expecting here. I think that's what we're expecting. So, I guess we will assert for now that we have float and the, what was it, length? No, it was vector elements. We're expecting this to be 3 for now. And then if this is true, then we can just call libgpu push input vec3. Right? That should be fine. That should be fine. Let's force a crash first by setting this to like 4 or something, just to make sure that we understand like that this assertion is working correctly. He's mad because we need to define this function. This is libgpu push input vec3. He takes in a shader and returns void. And this is just like a shader push input vec3. All right. So build. He's mad because it needs to be tried. So it's gonna be like I guess that means that this is going to return like a Boolean. All of these things return Booleans, and he's going to say like catch, return false, return true. Okay. And then here we'll be like, if this fails, I guess we'll just assert this is true. Asserts are a great way to error handle, man. I don't know what you're talking about. All right, looking good, looking good. Looking good. Okay, so the assertion that number of elements is 4 failed, as expected. It should be 3. We're expecting 3. All right, let's go. Okay, we understand it. That's pretty sick. Okay, so now we have to push the output as well. And I guess here we are kind of expecting the same shit, except we're expecting a vec4. Nice. Nice, nice, nice. And then that means we have to implement this thing, which is push output vec4, vec4, and push output. All right. Seems fine to me. Chillin', 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 chillin'. Okay. We're chilling. We're chilling. So that is inputs and outputs compiled. Wait, is this right? I'm mental. This is the wrong thing to do. We should be doing... This should be commands. I'm stupid. Load input reference. Yeah, I don't know what the fuck I was thinking. So this needs a... Fuck. Deref, inster, index. I think this is where... Okay, let's think about this. This deref instruction is trying to take this variable and store it in some output, right? So we're looking for, I think, we're looking at just like some SSA value, single, what does SSA stand for again? Single static assignment, right? Static single assignment. So this is coming, we're trying to put it into some static single assignment, which, did we print that out somewhere? We found that the other day. Did we lose it? Index here. So this is on index for sources, but we should have something similar here. So there should be like ner instruction, generic instruction index. Is it this? Can we print that thing? It's like inster input index. I think that's where it goes. I think that's what this is, but we have to double check. We do have to double check. Give him a sec. Compiling. Okay. So we have input index 1. So that's not it. We're looking for wherever 12 is in this thing. We're looking for wherever 12 is. So do we go back to print? Ner print. And this print deref instruction, it only prints the right side of the thing. I'll print def. Maybe not. So this is going to be print instruction for each instruction in the block. He prints instruction. Okay, so this should show the left side as well. Print indentation. Okay, nice. And then it's ner instruction as deref. Print deref. So it should be in here. Print def. SSA padding, bit size padding, def index. Instruction definition. Destination to store the resulting pointer. Ah! Okay. So this is in def. Instruction def. So this is, for us, it's deref, def. And then in here we have like index. Yeah, nice. That should be what we're looking for, I think. I think. Input index 12. There we go. That's what we're looking for. All right. So we are pushing a command, which is load an input reference given deref def index. This is where it goes. And it comes from var index. I actually don't know. And this needs like live GPU shader. So this is the SSA index here. And we want like the output or the input index. We're going to call this deref var index here and see if that gives us what we expect. I'm hoping to see 0 there. He's mad because we need to implement this thing. So this goes in shader zig. We do something that's like this. Pub export function. This returns a bool. His arguments are like shader is a shader. ID is E32 and input IDX is E32, which turns into shader push command. Which takes in a command which looks like this. Catch return false, return true. Okay. So source is input. This is input IDX here, and ID is ID. Okay. Build this. Build this. Let's see it. Let's see it. Let's see it. Okay. So here we have SSA index, input index 0. It's hard to be super confident in this, but I suspect that this is right. And we will just continue on and see. All right, what's next? What's next? So now it should be load output reference. And this should look exactly the same, actually. I think. I'm actually gonna leave this commented out because it's gonna be useful for later. And then our push output reference is gonna be very similar, except this is gonna say output. Boom. Pretty sure that's the same. Pretty sure that's the same. All right. So now we have our deref var. Next we have load deref. Okay, so that we called load in our command reference, I think. Load, yeah. So this just takes the value that was a reference and stores it in some output variable. So I guess we have libgpu.h. We just have the load thing now. And we'll just call this source and dest. Which means that we now need to look for this load deref instruction, which I think is in the intrinsic instructions because it's got like a little @ sign in front of it. So can we look at what lives in that thing? So we're probably going to take our like ner intrinsic. Okay, so this gives us a ner intrinsic inster. Uh-huh. Ner as intrinsic. Okay. Then we can start looking at this thing. What's in here? Instruction here has a type. No. Maybe we're looking at the nerd. Oh, here, intrinsic op. Yep. So this has gotta be a load of some form, right? Do these things have like op names kind of anywhere? I don't really want to like write the fucking serializer for this. I mean, they must, right? They have at load deref. Load deref as a string. Nice. So this is like an intrinsic here. Okay, so this is like probably some like generated code would be my guess here. So let's just look at nerprint.c again and try to figure out how they actually do that. So on print intrinsic is where we're going to be looking. And what are we looking for? We're looking for like basically off rip. First thing after the equals, the @info name. Here we go. Ner intrinsic infos. Nice. Okay. So here we're just going to be like intrinsic name. And its name here. Yeah, here we can see that when we jump here. Oh, this isn't source. So I guess I just missed this when I searched for load deref. How come if I search this directory for load deref, which is clearly right the fuck here, how come I don't find it? There's something wrong with my fucking grep. Like, what the fuck? Guys, am I fucking stupid? Hello? Hello? Oh, this isn't built. Never mind. Never mind. My brain's just on a. Okay, wait, this makes way more sense. Sorry, I got confused by the source in here. But source is Mesa. Got it. Never mind. This is generated file. Generated file. Everything makes sense. I'm not losing my mind anymore. I understand. Don't make fun of me. Or do, whatever. I don't give a shit. So we're just trying to confirm here that we see the load deref intrinsic. Intrinsic load deref, yeah, okay. So we are seeing that. And store. So we should hopefully see intrinsic. This should say ner intrinsic load deref. Hell yeah. Okay. So this or ner intrinsic store deref. These are our two fucking options. Yeah. So if these are true, then we should just say switch intrinsic is equal to ner intrinsic load deref. This turns into libgpu push command load. Am I forgetting? I feel like all of these commands should be prefixed with shader. Oops. Libgpu push is libgpu shader push. I don't know how that slipped by me. Libgpu push gets replaced with libgpu shader push. All right. And then we push a command load, which gets the value that we're loading from and the output. So we found before that the output was in deref def index. So we have the same here, intrinsic def index. Okay. So that's part one. I guess that's the dest. So now we need to somehow figure out how to find the source. How do we find the source? So that is after the parentheses in the intrinsic. So we go here and we're looking for after the parentheses here. So probably right here. Print source, instruction source, I. Which I think we've seen these before, so I think we can keep. So this is like intrinsic source 0 SA index. Nice. All right. We need the shader here as well. Okay. And then we need to implement this function. Okay. Okay, the shader is a shader. We have source u32 dest u32, which is going to push a command to our wonderful shader, which is going to be load with input is source and output is yield dest. Should be. All right, zig build. Oops. And build.sh. He's mad because SSA, this needs to be up arrow here. All right, we don't actually have to do the copy. I think that's fine. Okay. So that is this. We need to do load constant. This is done. And then store deref should be one command away. Right? So now it's just the move and load const. So that's here. So we want load const, presumably, is going to be like it's going to be like ner instr as load const. Ner load const. Right? Oh, he doesn't like this? Why? Ner load const instruction. My bad. All right. And so this thing presumably has the constant as well as the output. Right? Ner const value? Yeah. This is value 0. So probably this is supposed to depend on the type, but we're just not doing that right now. And we'll just say libgpu shader push command load const f32. Nice. That already exists in our header. Hell yeah. So we get to take our libgpu shader. We say that this is the constant. And presumably we just need some like SSA ID. So this just comes from the def again. So this is load const def index. The output. Boom. Simple. Okay, so here he's mad because of value is a union. So here we just go like F32 like this. And we probably need some like check for if it's actually an F32 smile. But for now, we don't have to think about it. Cool. So that's this, and all that's left is the actual move. So that's here. So this is going to be like libgpu shader push command move 4. I think is what we called it internally. And so this is going to be like we're going to say where's he going, and then we're going to say you have a float x, float y, float z, float w. And then this just comes from ooh, wait, nope. These don't take floats. These take channel references. libgpu shader channel ref. I'm okay with duplicating this on the C side, so we're gonna have the like unit 32T index. Sorry, I'm thinking. So this comes from an SSA. This comes from an SSA with a subcomponent, which I think is just this. Which I think is this. So we'll kind of do something like this. I don't know. Set expand tab stock is 4, shift equals 4. Okay. So shader, then we're going to have ID, and then we're going to say we have a bunch of channel references. X, there we go. I think this makes sense. I think. Which means that, well, we can get away without the struct definition here. If we do unit32t x ID, unit32t x sub ID. I like this better because then I don't have to define any structs and manage, you know, I don't have to manage like interop with Zigside. Now I can just do this without like importing any headers. Yo. Okay, so this takes in a shader, this, and then here we're gonna go like delete around word, go to the end of the word, and write U32. Okay. Boom. Boom. All right, good enough for me. So where's our test example of doing this? It's here. So push command, move for, input has source variable, index, x ID, subindex, x sub ID, y ID, y sub ID, z ID, z sub ID, and w ID, w sub ID. Okay. And the output is ID. Okay. So now we can say that we are trying to go to probably we have like ALU def index as the output. Nice. And now we have like a list here of like the index here. So this is index swizzle. So we're gonna do like, this is X here, YZW. Wait, hold on. Yeah, 1, 2, 3. 1, 2, 3 here. And then swizzle 0 on all of them. Seems right to me. Uh, 366, probably we need like, what's he bitching about? Catch return false here, probably. Oh, and then here we forgot to write bool here, of course. Of course! Expect type U8 found U32. Okay. Fine. Fine. And then here he's mad that I wrote try. That's a good point. Should be mad about that. It's not legal. Okay, and then build. He's mad that its command store doesn't exist yet. Ah, fine. That's such a little bitch. So store, he goes, this actually is not the same. Store takes 2 parameters. There's no output parameter. So he goes from 15. The first argument is where he's storing. So we kind of want to do it like the other way, I think. He's storing into this thing, which is our destination, and he is coming from this thing. Cool. Then we need to implement this. Okay. So this is just command store. And is it input output? Yeah, it is. Okay. So that seems fine. Fine. And what else is he complaining about? He's mad that there are too few commands to push command move forward, and he's also mad that I did not use a pointer for the ALU. Fine. What arguments am I missing? Push command move for. Oh, we did just forget live GPU shader here, huh? Fine. Now he's saying too many arguments. Shader ID, source 1, 2, 3, 4. 1, 2, 3, 4. This guy's just like a liar, probably. Oh, maybe I didn't type zig build here. I did. Conflicting types. So he is expecting. The fuck? Oh, yeah. There are conflicting definitions. That's a really good point. Oh, this guy's always whining at me. He's always like, could you like write the right code? And it's like, maybe leave me alone. Load constant F32. Only one left, I think. Pub export function. This returns a bool. And he takes in our shader. He takes in the ID as a U32 and the val as an F32. All right. Which we have an example of here, probably. Load constant. Boom. Load constant. Okay. In what language is he coding and what is he building? My apologies for the complete lack of information. One sec. So we are building a virtualized GPU. So the idea here is that we want to understand how a GPU works so that one day we can make our own. We need to understand what the software is expecting of the hardware. So we are implementing the entire GPU stack on Linux. We're making a driver for a new virtualized PCI device that acts as a GPU in a QEMU virtual machine. We are currently working on an OpenGL implementation for this thing. In the user space library Mesa. Mesa expects us to be, our GPUs to be able to execute shaders, which are like generic programs that run on the GPU. And we are slowly working through compiling our first shader and moving it over to the GPU and executing it. Where moving it over to the GPU means like ask the kernel driver that we wrote to give a sequence of bytes to this like PCI device that we've integrated with a virtual machine. And then that PCI device will run whatever code we write to actually like pretend to run, to like execute the shader, I guess. So we're kind of like working our way towards designing some form of like bytecode for this thing. But it doesn't actually technically have to be bytecode. It can be whatever, because we can just interpret whatever the fuck we feel like. We are writing partially in C, partially in Zig. So we're trying to write our like actual GPU library that does the actual GPU stuff in Zig, and then we're trying to use it from both QEMU and Mesa to like compile the shader, and from QEMU to execute the shader. So we're working on. Does it build? That'd be cool. All right, hell yeah. So this thing, we have like theoretically now pushed all of the instructions that we need to our like GPU shader compiler thing in order for it to run. So can we try now? Let's just make sure that we got everything right by trying to execute our shader down here. So kind of after all this, can we just call like lib GPU execute shader? And I guess we will give it like memory for an input and memory for an output. Or maybe we'll just, we'll just say like this. We'll just kind of feed them in, because this is kind of like debug code, so it's fine. We'll just hard code the inputs and outputs here. Yeah, that seems fine by me. Okay. So we'll just put a fix me on here. Debug code, please remove. And what do we expect to happen here? We're supposed to take in our shader. And this is basically supposed to do what we did in our test function, which is this. So we create a shader executor with our allocator. Okay. We take in the shader. This probably needs to be dereferenced. Yep. Then we try to execute this thing with a variable, and let's just look at what the outputs are. Like this. All right, so we should see an output of 1, 2, 3, 1. 1, 2, 3, 1. That's what we're expecting to see here. All right, sure. So he's mad because it's a try here. We'll just say like catch here and do like a little std log error failed to execute shader because of this reason. Okay, is there anything else in here? I think it is fine. Incompatible types, shader variable, and void. Sure, return here, I guess. And what's he mad about? Any here, probably? Yeah, there we go. Okay, build and run, moment of truth. Hopefully we hooked everything up right, and we see the correct vec4 1, 2, 3, 4 coming out the other end. Because we are supposed to just be, or 1, 2, 3, 1, I should say. Because we're just trying to merge our input vector 1, 2, 3 with the constant. Instead, we are indexing out of bounds and panicking, which is a shame. So can we, before we execute this thing, maybe print out the shader? Let's just make sure that this looks like somewhat sane. Command this, right? Let's just like start somewhere. Probably needs a new line on him. All right. Oh my god. It's so hard to type. Typing is so hard. All right, let's see it. Come on, baby. Tell me what's wrong. Okay, so we have load reference, ID 12, from input 0. Okay, so that lines up here. We're trying to put into 12 with input 0. Then we are trying to load output to ID 16 from input 12. That lines up here. We're trying to load a constant of the value 1.0 into index 11. All of that's fine. 15 is a output reference to index 0. That also makes sense to me. Then we execute the move command. Oh, we never pushed our inputs and outputs. That's why. So we need to inform our shader of what the inputs and outputs to our function are. So I guess that's probably here, right? The ner function parameters. Decal var, I assume that's what we're going to see here is this decal var shader in and shader out. but maybe not. Can we, let's look for that. Print ner print C. Where does that come from? Sorry for interrupting. What is the shader? No worries, no worries. You can choose. I can choose to just ignore you if I don't want to answer. So feel free to ask questions. Shader is basically like a funny way of saying program that runs on the GPU. So in the same way that like when you write a program for your CPU, you compile it, right? You write like int main void return 1, right? That like compiles to some code that executes on your CPU. He knows to like call the function main and return 1, right? Shader is the same thing but for the GPU, and the idea is that you run that program on like many inputs at once because the GPU is massively parallel. So if you want to like move every single vertex on a 3D model a little bit to the left, you can just say like return vertex ID plus vertex position plus a little bit, essentially. Hand wavy. Hand wavy. All right. So where is this guy doing the actual printing? Print if print block. Print block comes from. Do you think you know enough to write a doubly linked list in an hour with no internet? Enough Rust? Depends on what you mean by doubly linked list. You could definitely do it as like a vector. Here's what I would do. Here's what I would do. You've baited me a little bit. I want to answer the question, even though I shouldn't. I should focus, but whatever. What I would do is I would say like struct linked list would have inside him nodes, which is a vector of usize, right? Or vector of node, whatever, right? Doesn't matter. Now these would be actually option of nodes. Then I would do something that's like holes in the linked list is going to be a vector of usizes. And then what you could do then is you could have like your next is a usize and previous is a usize. And like whatever data you want in here, right? And then you could easily do it, right? Because now these usizes just are like stable indices into this nodes vector. And then if you want to like reallocate stuff, you just kind of pop whatever is the last element in holes. Now this kind of sucks if you end up in a situation where you one time allocate a bunch of nodes and then free a bunch of them in the middle, right? That kind of sucks. But otherwise, this works okay. This works okay for a lot of use cases. Now, if you're trying to write like an actually linked list, because that's cheating, then it's hard. It's just not easy. So I wouldn't really count on it. That's like a maybe I could do that, but I don't really know the answer. So, and like the Rust way is to like not do that, and linked lists are fucking stupid most of the time, anyways. So like, there's really like it just doesn't come up, you know. What is it? Print ner? What is like the entry point to this function? Print function. Here we go. Print shader. Ner print shader. Okay. So here we're probably in. We're not in the function definition, right? Decla function main has 0 parameters. Actually, pretty easy with RC and weak, but must be really careful. I could see that. I could see that. So we're probably looking at this shader variables, right? So it looks like we just kind of look for each variable with modes. We just want this. And we probably don't necessarily need with modes for each variable in shader. So we're probably just, well, what's modes? I guess that's important. Bit field bit I. Oh, I see. So he's trying to look for inputs and outputs. Yeah, that's what he's trying to do. So we can do this, but specify our mode as input or output, essentially. So we're going to be like, for each thing that is ner shader input, what is it? I lost it. It was, we have it somewhere. Ner var shader in. Okay. And then we can do the same. We can also iterate the outputs. Now, for each input, we're going to have to do something. So this is like lib GPU shader push input vec3. How do we know the type of this thing? So we have like var, right? What is this thing? For each variable in shader, for each variable in list, ner variable is what we're looking for. So how do I know like the type of this thing? Well, we already did this. We specifically looked at this. But I do not believe that this is right. Fuck. But maybe type here is right? Nice. Okay, hell yeah. Var type base type. So here we're just going to do the same shit where like for our output variables, we're like, I only want this to be like this. And then for our inputs, we only handle vec3 inputs right now because we're fucking lazy asses piece of shit, right? And now our shader should know what inputs and outputs he expects, which means that we should be able to run this without crashing. I'm hoping. Okay. So we got close here. We got output shader variable 1.0, which doesn't look right to me. Does not look right to me at all. So we made a mistake somewhere. Right? We said output any. So our output shouldn't, that makes it sound like the output was our constant, which is a problem. So it's likely, since we know that our test works, right? Oh, sorry, Zig build test. You guys put me in fucking Rust mode in my brain. Since our test works, we know that we're capable of representing this. We just probably made a mistake in the translation here. So can we look at the commands again and kind of see where that would be coming from? So we have the constant here at ID 11. Now, where does 11 come back into play? Store, input 3, output 5. This seems bad, by the way. Oh no, 3 and 5 are down here. Does that match up here? Yeah, 3 and 5 aren't in here anywhere. Which makes me think this load and store are fucking bogus. Because where's our load come in? 1216 seems right on our load. The store is like fucking bonkers bananas. I'm surprised that this output even works at all. Does everything else? We're seeing 3s and 5s on like load constant and load reference as well. Is it possible that like the shader compilation changed in some way? There are 2 outputs printed? Oh, thank you. You are correct, because we're running this for both the vertex and fragment shaders like fucking dumbasses. Thank you. You saved me a lot of time just now. But this does look right. 1, 2, 3, 1. That's actually really good. That's really good. Thank you. Thank you. Thank you. Thank you. So it looks like we have kind of, I think that we can kind of consider this compiled shader. And the next thing, well, we can call this generate shader from Mesa. That's kind of more a correct version of what we did. Now the problem here is that the next thing is that we need to like turn this into some sort of like binary representation. It is 3:39 now. That's probably doable, huh? We should keep going. And then maybe we will transfer to the GPU and execute tomorrow. It seems reasonable. Okay. So this needs to have, instead of like this like execute thing. Well, okay, let's first commit -m checkpoint for shader compilation. Oopsies. And we should do this as well in Mesa. Checkpoint shader compilation. And okay, so the next thing here to do would be to compile this into something. So I think what we should do is we should just do a quick little back and forth, probably. So maybe we'll do something that's like compile, which is going to return some sort of like byte stream, right? And then we'll have like a load. Okay. And it seems pretty clear that the things we care about are inputs, outputs, and commands. So maybe we set some sort of format where we have, I don't know, I guess we need like opcodes, right? And like arguments. So how do we encode this stuff? We could, for now, be lazy as fuck. If we wanted to be lazy, we could just like JSON serialize this thing and come up with like a sane binary format later. That feels nice to me because then I don't have to think. And we hate thinking around here. I assume that like a sane binary format is like you would have like opcodes for each of these commands, right? And then you would have like kind of argument packing where you would have to be very careful about how these things are represented in memory. Yeah, I don't know. That seems like a problem for another day. A problem for another day. If we're just trying to get the shader of the GPU, like fuck it, let's just be lazy. Yeah, let's just be lazy. So compile is just like the benefit here also is that if we can read it, then we can debug it nicely. And we can use that as a fake justification for why we're being lazy. So we can do something that's like std JSON stringify. And can we just like stringify ourselves? Almost. I'm curious, what is that program in the top right with your markdown? That's just Vim. That's just Vim. So we probably want like a compiled shader here. This is probably like a shader builder, to be honest, which I've said here before. But for now, we'll just leave it the way it is because I don't want to deal with that right now. And this is just going to be the same as this, but with slices. Okay. Simple, simple, simple. And then what's next? I guess like here we take like a compiled shader. Or we'll call this like a finished shader. I don't know. We'll call it compiled shader for now. I don't like that name either. I don't like this name. But this is gonna be like input types is self, input types items, output types like this. Okay, and then we just have like commands equal to commands items. Nice. We stringify this thing. So how does this work? We have a value, output stream, writes a value into the given SDIO writer. So we just say like to stringify is equal to this, and then we say like stood JSON stringify to stringify. You know, with like white space is equal to indent 2 or something. I don't give a shit. And then this is going to like writer. Our writer is going to be like an array list probably. Initialize self allocator. And then we're going to like at the end of this say that like our writer is our output writer. Boom. And then we just return output to own sliced. Wow. Okay. Then to load this thing back, we should be able to just be like compiled shader. I don't know. Maybe this returns a compiled shader, which kind of means that this kind of should live here. And then we kind of just do the inverse of this. So we do stood JSON value parse from slice into a compiled shader given our data, probably, with our allocator. Okay. And parse options here. I don't know. Do something like this. Then I think that this returns a parsed thing, right? So we have the value here, but this guy, if we want this thing to kind of act like he doesn't know that this was a JSON parse, then I think we have to do like something that's like defer val dinit and then return duplicated things of each of these commands. Unfortunately, because otherwise it's like unclear who owns what memory, but this makes it very clear. So we duplicate the command from value commands. Then this is the variable type from value dot input types and output types. Then we need like a dinit thing on this thing. And this is also with an allocator, probably. Which is like alloc free on self commands and input types and output types. Wowee! Look at us go. Okay, so now I think that we expose a API here to be like compile shader here, who returns like lib GPU compiled shader, which takes in like a void star data and a size tlen, right? But instead of doing this, I'm going to do it this way because I'm trying to avoid writing structs here to avoid having to import those structs in Zigland. It's easier if we just do data and len like this. And then we'll do execute shader like this. Fresh cut. I guess you could call it that. I did shave my head this morning. Felt pretty good. Hair was getting in my eyes. It was burning my eyes when it was raining. So big win for me. Big win. Okay, so execute shader now takes in data and len. So this is going to be like a C any opaque, and len is going to be a usize like this. So now our shader executor now has to actually take in a compiled shader, which probably means that in a bunch of places it's going to start to fall over, but we'll catch that when we need to. Here we're going to be like shader is equal to compiled shader load with our allocator, as well as data from 0 len. Let's do it like this, I guess. Okay. And then maybe we'll call this data len just for peace of mind. And then everything should just work. We just need to implement like a compile shader now, which takes in our shader as a GPU shader like this, and just returns shader compile. And then he actually takes in the data. So like this, and the length, which is a usize. And then we say, did we let this thing fail? We should let this thing fail. Then we can do try shader compile. Then we just say data is equal to ret pointer and len is ret len. Okay. Simple, 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 simple. We're going to have to make a free shader later, but you know, we'll live. Let's just see if this builds right now. Output writer is mad because 227. This needs to be variable. It's fair. I'm sorry, this has to be variable. Error union is ignored on stringify. True. Expected bool. Right, because down here we need to write or else return false. Then we write return true down here. Wonderful. This would be catch return false, not or else. Fine. Cannot dereference non-pointer type. So if data is equal to null, return false, or len is equal to null, return false. I guess we say like const data is equal to data opt or else return false. Want to do kind of like this. Boom, boom, boom. Does that compile? Cool. So shader dot star here. This is no longer this way. We should defer shader dinit with our allocator as well. This needs to be tried because he can fail. So we need to do or else catch return, I guess, for now. And commands is mad because duping requires you to write try. That's true as well. All right, no items at 481 because this thing used to be a array list. Now it's just a raw slice, and we have the same problem with output types here. True, true, true. So true, these guys, man. All right. So now let's try down here to compile the shader. So we'll kind of do like libgpu compile shader with data and data len. And then we should be able to execute the shader with data and data len like this. And hopefully, we kind of see the same behavior. That's what we're hoping for. We're hoping to just see that lovely, lovely vec1231 as our output. That'd be so cool. Hell yeah, baby. Hell yeah. Dude, that's sick. That's so sick. And then we can even print it out in the middle just to be sure that we're not like forgetting something important. So how do you do this? You do like %*s and then you pass in data, len, and data or something. Is it the other way around? Data and data len? No. I thought it was like this. Printf, like size len. .*s. I was close. No, he's still number, size, letters. Oh, this specifies the width, this specifies the precision. Is it that like we need to do an int cast here? And car star like this? Yeah, maybe that's what they want. Maybe that's what they want. Because it's not null terminated, I don't think. Because we are shitty C API citizens. But here, yeah, sick. So we can see that this is our compiled shader. We have commands, load reference. Here's our commands and our inputs. So we have a vec3 and a vec4. And then we compile that thing and we run it and we get vec1231. Pretty good, pretty good. So, you know, there's something really stupid about this. Lots of things really stupid about this, but this is a like good enough first implementation, right? We're pretending that we have infinite registers. Where our bytecode is JSON, which is fucking stupid. But you know, it's definitely good enough for now. I'm pretty happy with that. We have proven to ourselves that we can do the round trip. So now the last piece of the puzzle is going to be trying to like upload the vertex buffer to the GPU and trying to like pass that thing through. But we are at 3:57, which is almost a perfect 2-hour stream. So we're going to call it there. Thank you so much for watching, you guys. If you like what you saw, we stream most days at 12:30 Pacific time to 4 o'clock Pacific time. 12:30 to 2 is kind of more of a different vibe than what you're seeing right now. If you're watching right now on YouTube, you're seeing the 2 to 4 segment. Or on Twitch. I guess if you're watching either on Twitch or YouTube, you're seeing the 2 to 4 segment, which is kind of like we try to get into like prototype mode, which is like we're trying to implement new features, we're trying to rip through them quick, and we're trying to just like do whatever we got to do to get like a thing implemented. Kind of the 12:30 to 2 segment, we call it happy hour, and it's a lot more like background info type stuff. So we're like maybe writing tests, we're maybe refactoring some of the garbage code that we wrote into something like more sane and committable. Sometimes we're doing research. Today we were reading about PCI and trying to understand exactly the mechanism that like DMA uses when you do like direct memory transfer with a PCI Express device. Like, oh, well, there's like these like packets and like how does like the PCI controller interact with the memory controller so that like to block the CPU from using the RAM lines when the PCI device is using it. You know, we were kind of looking at like that type of stuff. If you want to see that type of content, that's archived on Patreon on YouTube member streams. If you just are happy with the 2 to 4 segment, which is really all you should need to track a project that we're working on, that's on the YouTube, just kind of like in normal playlists. Let's see, what else? I think that's really all I really feel like I have to plug. Let's say goodbye to YouTube and Twitch. Let's find someone to raid.